You're listening to Let's Talk Creation with Todd Wood and Paul Garner, the creation show where we learn, grow, and worship.
Well, welcome back to another episode of Let's Talk Creation with Paul Garner and Todd Wood. I'm Paul Garner.
And I'm Todd Wood.
We're very glad to have you join us again for another great episode. And if you're a new listener, viewer, you are especially welcome. And of course, we want to welcome back all of our regulars. We're delighted that you're here. Do remember, if you're not already a subscriber, hit that subscribe button, hit the notification bell so that you get notice of all of our episodes, all of our content. If you're on a platform where you can leave a review, why don't you leave a positive review? All of that really helps with engagement, and we are very, very grateful for all of your support. Today, Todd, we have an interesting episode. It's actually the first of a two-part set of episodes where we're going to talk about comets. This was kind of my idea. I was out comet watching fairly recently. Yeah, there was a new comet in the sky back in sort of mid-October.
Right.
And I went out to have a look for it a few nights running. It was cloudy, so I didn't see it. And then one night it was clear, still couldn't see it with the naked eye. Turns out it was just too faint for me to see with all of the light pollution around. But I did manage to photograph it with my iPhone when I put it on a longer setting and longer exposure. And I managed to get a nice photo of this new Comet A3.
Wow. Okay.
So that was great.
Yeah, we tried to look at it here, but we have a mountain right in the way.
Right.
We live right on the edge of this, the Cumberland Plateau. So,
yeah,
the few minutes it was visible after sunset.
You had no hope of seeing it because it was quite close to the horizon as well. So, yeah. Anyway, that got me thinking. We should do some episodes about comets because they're a fascinating class of solar system objects. They're often spectacular and quite beautiful to see. And creationists, of course, have appealed to the existence of comets as an argument for a recent creation and a young solar system. So I thought, why don't we take a look at the science of comets? And so that's what we're going to do over these two episodes. In this first part, I think what we'll do is we'll look at some basics. We're going to look at what comets are, the different types of comets. We'll look at the history of how comets have been studied. We'll think about the structure of comets. And then in part two, we'll sort of dig into that question of the origin and age of comets in a bit more detail, and we'll consider sort of evolutionary and creationist perspectives on all of this. Now, of course, neither you nor I have any expertise in astronomy.
Especially me. Comets. Yeah, sorry, I don't know much about comets.
No, so we decided we would invite back a guest who we have had on the show before, a very special guest who has a lot more knowledge and expertise in the study of comets than we have, Dr. Bob Hill. Bob, welcome to the show once again. It's great to have you with us.
Glad to be here. Looking forward to this.
Yeah, so are we, very much. Now, for those who don't know, Bob is an astronomer. He has a PhD in astronomy. He is a member of the American Astronomical Society. He's an associate professor in the Department of Chemistry and Physics at Bob Jones University. And you're also president of the Creation Research Society. So quite a CV. Bob, before we get into comets, how are things going at CRS? You had a very successful conference back there in the summer. I was there, but why don't you just tell our viewers a bit about that?
Oh, our conferences just get better and better every time we do these. We've really hit our stride. We've got the right mixture there of technicality and then new stuff. Because the goal of our conference is not the ICC.
Yeah.
We want, people who's got like cutting edge things or trying it out, and you bounce ideas around. And one of the big things about our conference, we build time into it so that you can really interact with the scientists and just have discussions. It's not rush, go to this lecture, rush, go to that lecture. We plan on people having lots of time just to chit chat and bounce ideas around, and that's very powerful.
Yeah. And there was a great astronomy track this year, I thought. I heard a number of speakers. Really good astronomy talks. And I particularly enjoyed your talk about angular momentum in the solar system. And that made me rethink some things that I've talked about in my public presentations before. And I thought, okay, I've got to go back and think again about some of this. So that was very helpful. Check out the Creation Research Society, check out the summer conference, and this 2025 you're going to be in St. Louis, I think. Is that right?
Yes. So we got our current lab director is from that area.
Yeah.
And then the people who are organizing this are from that area as well, good friends with him. This would be great.
Yeah, that's great. So do check that out, everybody. Well, why don't we come to comets then? That's what you're really here to talk to us about. This is a subject that, often attracts creationist interest. And because it's been used, as an argument for a young solar system, which we're going to dig into, particularly in the next episode. But why don't we begin with some real basics to get us all up to speed? So why don't we begin with, what are comets? Where does the word comet come from? So just tell us what they are.
Okay, the word comes from Latin or Greek, cometes, which basically means hairy star. Because to the ancient people, any light in the sky was a star.
Yeah.
You had fixed stars, like you normally think of as a star in constellations. You had wandering stars, those were planets, shooting stars, hairy stars, etc. Just a light in the sky.
Yeah. So presumably hairy star because of the tail, is that right?
Yeah.
Yeah, the tail of the comet. Yeah. Yeah. So what are comets then? I mean, what kind of objects are they? Okay, now
they end up being small, icy, and rock. Yeah, so you typically have a comet nucleus. Yeah, think 5, 10, 20 miles. Not big enough to be spherical. Think like potato. That's a good description of the shapes of these things. I tell my students that, I'm like, yeah, that's it. And they've got rock in there, but they got ice, different kinds of ices. And a lot of these end up having this dark crust on them from just like stuff they picked up in the solar system. And then when they get near they have very elliptical orbits generally. And so when they get close to the sun, they get around Mars, the sun starts heating things up and the ices start sublimating. Then you have solar wind and the light pressure pushing out stuff that causes the tail.
Yeah. So they're basically sort of small, icy potato shaped objects, but not just water ice. I mean, you said different kinds of ices.
And all kinds of stuff.
Okay. Yeah. And there are different types of comets, aren't there, based on their orbital characteristics? So just sort of help us to understand what the different types are.
Yeah, we've got short period comets. They typically have orbits less than 200 years. Yeah. That's just a rule of thumb boundary. And generally, they are roughly in the same plane as the Earth in their orbit. So that's the ecliptic. And they generally orbit prograde the same direction as the planet's orbit. And then they kind of divide these up a little bit on what their periods are. The Jupiter family orbits just like 20 years or so. And then Halley type orbits bigger than 20.
Okay. So when we divide comets up like that on the basis of their orbits, I mean, is that just an arbitrary division? Because you've said there are some other characteristics too that distinguish short period, and then we're going to come on to long period comets. But what about these Jupiter and Halley family comets? Why are they divided up that way?
I think it comes down to just where they're at in the solar system.
Okay.
If it's a Jupiter family, they'll burn up a whole lot faster than the Halley type.
Right.
And if the Jupiter family, it's probably going to have a more circular orbit. Mm-hmm. And then the Halley type, a more eccentric orbit.
Right, I see. Okay. Yeah, so short period comets, they have orbital periods less than 200 years, and then you've got long period comets.
Long period comets orbits greater than 200 years. And these tend to come from all directions, not just in the ecliptic plane.
Okay.
For example, the comet here in October Suzhenshan Atlas,
Yeah.
named after the observatory in China, in Nanjing, and then the Atlas was in South Africa. The robotic surveys. That was a long period comet, a very long period, like 80,000 years for the period to start with, and has a very inclined orbit to the plane of the Earth's orbit, 139 degrees or so.
Yeah.
Just clearly different.
Yeah. And they can orbit in a prograde or retrograde direction. So
yeah, I think they can do anything.
Yeah, so kind of same as the planets, or it can be opposite way to the planets. So yeah. Okay, so that's interesting. So we got these short period and long period comets. Yeah, so this new comet that appeared in the sky. So you say it has this sort of orbital period of 80,000 years. So this is the first time we had seen this comet. When was it first detected? Do you know?
It was first detected almost simultaneously by the Purple Mountain Observatory. That's the translation of the Jinhao thing. And the one in South Africa, almost simultaneously. There's robotic surveys. They're just looking for something which moves against the background stars. At first, both of them thought they're asteroids. Yeah. And after then they get like 1,000 observations that get a precise orbital period on the way in. And I think it was like a year or so ago.
Yeah.
Before it got close enough to have a tail.
Yeah. So that's very interesting. So so we've got these small icy objects. They have different orbital characteristics. Tell us a bit about the history of comets, because people have been observing comets for a very long time before we kind of really understood what they were. But tell us how in ancient times, comets were viewed by people. Tell us a bit about that.
Generally, people thought of a comet as a harbinger of doom.
Okay.
That's what I think. That's what I've been thinking.
Okay. Especially in Europe. For example, the Great Comet of 44 BC appeared soon after Julius Caesar was assassinated.
Right.
Yeah.
And so that especially got things going. Halley's comet was recorded by Josephus. They were recorded many times. Only when they figured out what comets really were, they start peeking out these things. But for example, in AD 66, Halley's comet came around. Jewish historians thought, and he thought it was related to the destruction of Jerusalem in 70 AD.
Sure.
Later, Halley's comet appeared over England around 1066 AD.
Oh,
yeah.
It's actually depicted in the Bio Tapestry.
Yeah.
And so so you can see where this harbinger of doom stuff comes from.
Yeah.
Chinese emperors, they had professional astronomers way back then. They had their own version of astrology, too. And, of course, having a stable civilization for thousands of years, lots of records. And so and they thought somehow the comets related to the balance of yin and yang. And so Emperor Ruzhong of the Tang Dynasty, a comet appeared like 712 AD. He took that as a sign that he had lost the mandate of heaven and abdicated.
Okay.
Yeah. It's very interesting. And I mean, even in quite recent times, people have looked at comets in the sky and thought that they kind of predict, terrible events. I understand, back in 1910, Halley's Comet also appeared and was one of the contributory factors to political unrest in China.
Yeah, the Xinhai Revolution, 1911. They thought, the Qing dynasty, which is weak anyway, had lots of trouble. They thought it lost a mandate of heaven and ended up being part of the Republic of China being formed.
Yeah. So it's amazing how persistent this idea has been. But what did these early observers think that comets were? I mean, did they have any idea, what they were at all?
The only one I've heard about was Aristotle, who wrote about everything.
Okay.
He knew everything.
And wrote Intelligy, which is amazing. He thought they were in the atmosphere.
Okay.
Some disturbance in the atmosphere, make like maybe lightning or something.
Okay, so what? Okay, so he thought that they were actually a kind of more earthbound sort of phenomenon.
Yes.
But when did our modern scientific understanding that these were actually objects sort of out in space, how did that begin to develop, and when did that happen?
Yeah, that ended up coming about because of Tycho Brahe, 1546-1601. He had the best pre-telescope observatory in the world. He invented scientific instruments make very precise measurements of angles with time. So on this day, at this time, this planet Mars was this many degrees away from this star, or this many degrees away from this star, that kind of stuff.
Wow.
He had thousands of measurements of the Great Comet of 1577. And with records from other places on Earth, I realized that wasn't in the atmosphere because you could see it too far out.
Okay.
I think you can see parallax measurements, which is amazing.
Okay. Wow.
And so it's farther out than the moon.
Yeah. Yeah, so he was a very significant early astronomer. I think people may sometimes associate his name with his sort of geocentric system. Is that right?
Yeah, he never bought into heliocentrism.
Mm-hmm.
Well, the thing I just mentioned there, we just talked about, that convinced him that Ptolemy was wrong. The Earth center. But yet he could not measure parallaxes of stars.
Right.
And so Copernicus had to be wrong. So Tycho came up with his own version. Earth was the center of everything. The sun ran around the Earth, and then everything else went around the sun.
Right. Okay. Yeah.
Wow.
Yeah. But he was the first to sort of recognize that comets were basically out in space. They weren't in our atmosphere. And did I understand rightly that he also sort of worked out that the tails of comets
pointed away from the sun.
Always point away from the sun. Yeah. Yeah.
Yeah. You watch a cartoon or something, and we imagine, the tail trailing behind the comet as it moves across the screen. That's what a meteor does.
Yeah.
Yeah.
No, you have a clear orbit, and then the comet tail always points away from the sun. And if you track in the sky, you can see that.
Yeah. Yeah.
Oh, yeah.
You like see where it was last night, see where it is tonight, tomorrow, and then see where the tail is relative to the sun.
Yeah. And Isaac Newton also made observations of comets, but originally he didn't publish those. Is that right? But it was sort of significant in the thinking of Edmund Halley.
Yes.
Tell us that kind of story about.
I don't think he actually observed comets. He was a theoretician.
Yeah.
Brilliant, of course.
Okay.
And apparently he'd actually worked out orbit theory and stuff that would apply to comets and how to actually determine their orbits from a few measurements, but he didn't publish it.
Right.
So Edmund Halley he's been studying Halley's comet. He used to historical records. Hey, there's a regular appearances like every 76, 77 years. Maybe it's the same thing. Went to Newton, asked him about it. He's like, oh, yeah, I figured this out about 10 years ago. It's in this drawer someplace.
Classic scientist, yeah. Oh, yeah, I figured that out. What did I do with it?
Yep. Well, he didn't like publishing or something, so Halley realized this is impressive and got together with some other guys, and they put up the money and then convinced him to publish stuff. And you get the Principia out of that.
Wow.
Yeah. Wow.
Good grief.
Yeah, this is very interesting. So it was Halley who kind of recognized that, Newton's calculations really made sense of the things that he was observing. So Newton was the theoretician, and and Halley was kind of piecing together the observations.
And since Halley could predict the next appearance of the comet, he named it after him.
Yeah. And it's Halley's comet, not Halley's comet, because I've heard it pronounced that way, and that's not correct.
There was a 50s rock band, Bill Haley and the Comets, I think it was. And people are, and I think people start pronouncing it that way since then.
Yeah. So it's
like
Edmund
Halley.
Yeah, and Halley died. I mean, he kind of predicted when the next appearance of this comet was going to be, but he actually died before it appeared the next time. Is that right? So yeah, he didn't see that confirmed, but it was confirmed, and so that's why they named Halley's comet after him. Okay, so that's really interesting. So he began to realize, these are returning objects. They're coming back on these elliptical orbits. Mm-hmm. When did people begin to sort of understand something about maybe the structure and composition of comets? How far back can we sort of trace, that kind of knowledge, that sort of information?
Let me see. So just start making catalogs of these things. But as far as actually what they were, he had to wait until like the 1800s, probably. I started doing astrophotography and doing spectra of the tail.
Right. That makes sense. Yeah.
Then you figure out what's in there. And then it was Fred Whipple in like 1950. So, these things are basically rocky with ices. So you call it a dirty snowball.
Yeah.
Yeah. I mean, that was what I kind of grew up understanding was comets were dirty snowballs.
Yeah.
That's not strictly correct these days. It's kind of they're a bit more icy. Is that right? Or a bit more dusty rather than people thought originally. More dusty. Yeah.
That's what makes them dark and increasing the albedo.
Yeah, and people have been sort of collecting observations, compiling catalogs. I mean, how many comets do we know about? Does anybody keep a kind of running total anywhere?
Oh, yeah.
Of how many?
There's catalogs. I don't know what they are off the top of my head.
Yeah.
But, for a good while there, we're discovering like maybe 18 comets a year.
Wow. Okay.
Well, you have all these amateur astronomers. They would have like contests among themselves. Who could discover the most?
I think this is one of the amazing things about astronomy, that amateur observers can still play an incredible role in scientific discovery in the field of astronomy. This is always amazing to me.
Yeah. And so guys just looked at the skies. They knew what the sky looked like. They're looking for these kind of things. They want to get their name attached to the comet. But once you got these robotic surveys, it takes a picture of the sky today. Tomorrow it looks at something else, Then it comes back and looks at the same spot again. You're looking for something that moved. And the computer program is actually pick out the stuff that's moving. Then it starts tracking those among the various times. And so you might pick up 5 or 6 asteroids, a comet, etc. Just doing that.
Yeah, amazing. So amateurs can really make, besides these kind of systematic surveys, just amateurs as well as kind of spotting things in the sky can contribute. And 18 new comets every year. I mean, that's just incredible.
That was just the amateurs. Now it's skyrocket.
Oh, really? It's far more than that. Okay.
Wow.
That's because you're seeing when they're farther out.
Yeah.
Not having a tail.
Yeah. Wow.
Because I don't remember hearing about. I mean, this last comet that went by. That seems like I haven't heard about comets in quite a while. But I guess there's a lot more than we know about. I guess they're small. Yeah. Is that what's going on? Are they just really small and you can't really see them very well?
Well, the robotic survey ones that are found, they find that when there's no tail, or there's a very small tail, and they're dim. And then once they figure out it's a comet, they can start tracking it way before you'd see it with the naked eye.
Yeah. Yeah. Now there was a comet that appeared in the sky just a few years ago. I think it was when we were all kind of locked down because of COVID. That one I remember seeing, and it was visible to the naked eye. I could see that comet quite obviously in the sky. And then the one before that I remember seeing was back in the mid-90s. And that was in the sky for quite some time and very, very obvious, a very bright comet.
That's probably the only one I can remember really seeing.
Yeah.
Just going outside looking.
Yeah. Yeah. They're fantastic to see. So yeah, definitely if you get the opportunity, viewers and listeners to see these things, definitely worth making the effort to go and see them. They really are quite spectacular, particularly the bright ones. Bob, we're going to think next episode more about the origin and age of comets, but just give us a brief sort of introduction here. What are the different perspectives on sort of origin and age of comets between sort of creationists and evolutionists? How do they view these differently?
Okay, so evolutionists think the solar system formed from a cloud of gas and dust. And gravity, electromagnetic interaction started making stuff clump together. And then finally gravity took over. You got planets that way. And so they think comets and then asteroids are the leftovers.
Yeah. So would these be, I've heard this term planetesimals.
Yes. They get like a kilometer or so in size, call them planetesimal. Then gravity can take over, pulling stuff together.
Yeah. And the bits that kind of get left over that don't become planets and moons, they become the smaller objects, the asteroids and the comets and so on. Yeah. And planetesimal, I mean, these can be rocky objects. They can be presumably metallic sort of objects. They can be icy objects. Is that right? Planetesimals can, so it can encompass all of that.
Like the asteroid belt between Mars and Jupiter. You have rocky stuff. You have metallic stuff. You don't find many icy ones there. Those are farther out.
Yeah. So that's kind of the evolutionary view. Now, from the creationist view, I mean, how do we see it differently? We still think these are primordial objects, right? They date from the origin of the solar system. Is that correct?
That's pretty much what I'm thinking, with other astronomers are thinking. We're creationists.
Yeah. But obviously much more recent
biblical
origin. So biblical time frame. So only thousands of years rather than 4.5 billion years. Yeah.
So can I jump in here with a question? You mentioned the comet that's out there most recently this year. You mentioned that it had, I think you said it had a period of 81,000 years. Now, as a young age creationist, that's older than the entire universe, right? So, can you help us understand how did they come up with that as a period? And it seems like, is that a comet or is that just some random thing that flew by our solar system? I don't. What's your perspective on that period calculation?
Well, they're basing that on, they measure the positions in the sky at certain times. You're doing, it's called astrometry. And so you end up calculating what the ellipse would be.
Okay.
If it went through the whole thing.
Okay.
Then you apply Kepler's third law of planetary motion. If you know the semi-major axis, you can calculate the period.
Yep. Okay.
That's where that comes from.
Okay. So that's basically if the universe was that,
if it had enough time to go through the complete ellipse,
that's what it would be.
That's how long it would take.
Okay. But it doesn't say anything about the comet actually having gone through a full orbit or not.
Right.
Yeah. Okay.
Right.
That makes sense.
Because it could have been created at any point along its orbit. Right. So yeah.
And we haven't seen the entire.
Yeah.
All right. But you could have comets that have orbits that are presumably that big. They just, from a young age perspective, they may not have ever actually finished an orbit. Yeah. Okay. All right. Got it. Cool. Very good.
Yeah. Yeah. Good question. Well, let's kind of then think, zoom in, if you like, to the comet itself and think about the structure of comets. What you mentioned earlier, that comets have a kind of a core or a nucleus and a tail. They also have a kind of an atmosphere called a coma. But I mean, can we take each of these sort of in turn and just say a bit about each of these? Maybe begin with the comet nucleus. What would what can we say about a comet nucleus? What do we know?
Okay, that's the physical body that's there all the time.
Yeah,
the nucleus. Like some of these can be like 0.6 miles, 6 miles, maybe 10 miles in size, and they're shaped like potatoes. It's a very good description. Because they're not big enough for gravity to pull them into a sphere.
Mm-hmm.
Okay.
Rock needs to be about 1,000 kilometers in size or so to do that.
Mm.
So that's about how big they are. And then they got this rock. They got rock in there. They have ices. You can have carbon dioxide ice, water ice, methane ice, ammonia ice. And then they'll have like a dust layer on the very outside.
Mm. Yeah.
And the ices, carbon dioxide, carbon monoxide, methane, ammonia.
And we've actually done some quite detailed observations of a comet nucleus, haven't we? There was a spacecraft, I think, back in the mid 2000s that NASA sent up to study a comet nucleus.
Yeah, it was a deep impact. But before then, the 86 apparition of Halley, European Space Agency sent three probes to do flybys.
Oh, wow.
Okay.
And the Giotto, they kept getting like three of them. Each one got closer than the other one. That way they figured they'd get something back. The Giotto probe got it the closest. And actually got a picture of the nucleus and stunned everybody. It looked like it was covered with black tar. There's dust and stuff that it picked up, and you see jets shooting out of it. It was really an impressive picture. That was like the first time we really did that. Since then, it's like, well, let's find out what's really there. Like the deep impact when you mentioned Comet 9P Temple 1. Actually shot something into it and blew stuff out. And they examined the debris. And this one had less ice than they expected.
Yeah.
And fine dust and powder, and they had other ones. The European Space Agency, Rosetta spacecraft, Comet 67P, Churyumov Gerasimenko, how do you pronounce that? And put a lander on it. They get kind of the same kinds of thing.
Yeah. This amazes me. It amazes me that you can actually land, a little spacecraft on one of these comet nuclei. That just staggers me because they're not very tiny, big, these comet nuclei, and the calculation to actually put that lander down on that object that's moving so fast, it just amazes me. Incredible. But I remember the Deep Impact mission where they kind of fired this washing machine sized sort of impactor into the comet, and that was kind of where they found that it had a lot of dust in it, and so this sort of dirty snowball model was sort of modified a bit. Seems to be more dusty than they expected. So that was interesting.
Well, these newer studies, they're finding the old view was you had asteroids and you had comets. Asteroid was a rock in space. Comets was a rock with ice in space.
Right.
Okay.
Well, no, these new ones, how much ice do you need to have where this is called a comet?
Right.
There's like this debate now. Where's the bound between asteroid and comet?
Yeah.
Not surprising.
Yeah. Yeah.
Yeah.
And what do we know? We've talked about kind of the exterior of the comet. What do we know about its internal structure? Is it layered? Is it the same all the way through? I mean, what do we know about it?
We know there's rock in there.
Yeah.
layers. They're not exactly sure yet. Is it alternating layers of rock and ice? I don't think we know.
Mm-hmm.
Or is it kind of like gravel,
mm-hmm.
ices in between the pore spaces?
Mm-hmm.
Mm-hmm.
They're having a similar debate with some asteroids.
Mm.
Is this 5-mile diameter rock in space? Is that solid? Or is it a bunch of boulders with just dust filling in the gaps?
Yeah. Yeah.
And that one's an important debate. They're worried about Earth crossing asteroids.
Yeah.
Oh, yeah.
And what do you do to cross the Earth's orbit? I mean, do you nuke it? Do you do this?
Yeah. So there's still some things we don't know about comets. We don't know exactly their internal structure, which is interesting. So
we have to actually land something on it, drill into it, pull the drill core out, and bring that back.
Yeah. Wouldn't that be something? That would be amazing. Yeah.
That sounds elaborate.
Yeah. I'm sure someone's thinking about it.
Oh, I'm
sure.
Guaranteed somebody's thinking about it. Probably Elon Musk is thinking about it.
Yeah. That's great. So that's the comet nucleus. And then I mentioned this thing called the comet's coma, almost like a kind of atmosphere around the comet. Tell us a bit about that.
When it's far from the sun, it's just the nucleus.
Right.
And all the ices are solid. And it's pretty dark and inactive. When it gets, say, around, and it starts coming in closer to the sun, it gets, say, around Mars orbit.
Mm.
And the sunlight's enough to start warming up the ices, and they start sublimating. They go direct from a solid to a gas, skipping a liquid phase.
Mm.
And that builds up kind of an atmosphere, the coma.
Yeah.
And when that sublimate also pulls out some dust from the surface, and so it starts building up this coma, which can get quite big.
Mm.
And then when it gets closer to the sun, pressure from sunlight and the solar wind start pushing these particles and stuff back.
Okay. So that forms the tail.
That forms the tail.
So the tail is kind of an extension of the coma, in effect. Yeah.
It's been pushed away.
I hear people talk about comets burning out. Is that formation of the tail going to eventually erode away the whole thing? Is that what that's about?
Yeah, because every time it comes around, it loses some of that ice. So it's a mass conservation problem.
Okay.
Yeah.
It's like every time it comes around, it loses, a tenth to a percentage, 1% of the mass.
Yeah. That's going to be important.
You can only go around so many times to have ice left.
Yeah. 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 So the creationist young age argument, that's going to be really important. This kind of mass loss issues. So we'll definitely come back to that. So we've had various sort of missions that have gone to look at the comet nucleus. What about the coma? What kind of observations have been made there? We've presumably missions have gone to look at it, take samples.
That I'm not as certain of. Yeah, I think we've done that too. Try and get some dust grains. The Stardust probe in 2004 got some dust grains from Comet 81 Wild 2. And they found the coma of long period comets are different from the coma of short period comets. The long period comets, they think, are more pristine because sunlight hasn't affected the surface much.
I see. Yeah. Yeah.
Right.
Yeah, because the long period comets spend more of their time basically further from the sun.
Further from the sun.
Yeah.
Where short period comets had come around more often over the sun can affect them.
Yeah. Yeah. So you mentioned the tail, which is kind of an extension of the coma. But comets have two different types of tails, don't they? They have the kind of the dust tail, but there's also the ion tail. What's the difference between those?
Okay, so the dust tail That's when the sublimation takes place, pulls dust particles up with it.
Mm-hmm.
And then sunlight hits those dust particles and actually exerts a pressure is over a long period of time of these very small particles, and actually pushes the particles, those dust particles, away from the comet nucleus. And those are often curved, yellowish or kind of a whitish. That's because they're scattering sunlight.
Mm-hmm.
Now the ionized gas is taken away and makes up the ion tail or the gas tail, depending on who you're reading about. And now the solar wind is actually smacking that thing with high energy particles, high energy charged particles. And so the ion tail ends up emitting its own light. It's exciting, and then electrons are jumping higher orbits, coming back down, giving off their own light, giving a bluish color. That's especially from carbon monoxide.
Yeah. And I've seen photographs where you can actually see the two tails quite distinctly. So then,
and you can see through the tails. It needs to be millions of miles long. But if you took all the contents of the tail, you fit that in a suitcase.
Wow!
It's just spread out and excited, so it gives off light.
Yeah, that's just amazing. Wow. Such a small amount of material is visible like that. Yeah. So, over such incredible distances.
I think it's one of the Halley's comet in like the late 1800s. They did some spectroscopy, found it had cyanogen in the tail, and Earth is supposed to pass through the tail. And so, as end of the world, people are selling gas masks. Insurance companies are selling comet insurance.
Harbinger of doom. There it is.
People were selling comet pills, protect you from this.
Oh wow! Okay,
something's never changed
in America.
Yeah. But we do see sort of meteor showers that are related to the Earth passing through sort of debris left by comets. Is that right? Is that what causes meteor showers?
Yeah, regular meteor showers. As a comet goes around the sun, debris is left behind. And when Earth passes through that debris field, that gets pulled in, the Earth's gravity pulls them in, they burn up in the atmosphere. You get meteor showers.
Yeah. Wow. Yeah, that's amazing.
So Halley's Comet, is there a meteor shower from Halley's Comet?
There's two.
Whoa.
One so you got the orbit, and then you get the orbit of the Earth, and the comet's orbit is doing this.
Mm-hmm.
So once when you get a meteor shower when the orbit is coming up, once when it's going down.
Does it have a name? Did either one of them have a name? Would audience members know?
I don't remember what the names are.
Okay, yeah. That's fine.
I do my PowerPoint presentation for my astronomy class. I got the name right there.
Oh yes, of course.
Yeah, no, that's fascinating. And sometimes comet tails do strange things because they kind of get disturbed by things going on in the local space environment. So you get strange things.
What the solar wind's doing, what magnetic fields of the sun are doing.
So you get kind of bends and kinks in the tail and sort of brightening of the tail and all kinds of interesting things. So yeah,
depends how active the sun is.
Yeah, that's brilliant. Well, comets are fascinating objects. I said this at the outset of this episode. There are so many interesting sort of aspects to comets. What have we learned? We've learned that they're small icy objects. They have highly elliptical orbits. So they come very close to the sun, but they also sort of travel far out into space. We've learned that they have been regarded historically as harbingers of doom, associated with plague and war and political unrest and all these kinds of things. But we also, thanks to our scientific investigations, we know a great deal more about comets today than people did in the past. We know that they have this sort of icy, dusty core. We know that as they come close to the sun, they develop this coma that extends into this tail, which is often what makes them very sort of bright and impressive objects in the night sky. So comets are really fascinating things. But of course, they also give us some insights into the origin and history of our solar system. And so that's what I'd like to come on to in our next episode. We'll have to wrap this one up for now. But creationists have often appealed to comets as evidence of recent creation. And so in our next episode, what I want to sort of dig into a bit more with you, Bob, is where do comets come from? What is the source of short period comets? What's the source of long period comets? And what, if anything, can they tell us about the age of our solar system? So we'll come back to that in the next episode. Don't forget to like and share our episodes. Remember to subscribe. Do make a donation if you're able to. Go to our website, letstalkcreation.org, and there are all the ways that you can give to help support the podcast. And Bob, that's been a great conversation, and we'll be back with our viewers in a couple of weeks' time. We'll see you then.
Thanks for listening to this episode of Let's Talk Creation. For more information, visit us at letstalkcreation.org, where you'll find an archive of past episodes and all our show notes. If you'd like to leave a comment or make a suggestion, you can find us on all the major social media platforms. Let's Talk Creation is brought to you in the U.S. by Core Academy of Science and in the U.K. by Biblical Creation Trust. As a listener-supported ministry, we are grateful for all of your financial support. Find out how you can make a contribution at our website, letstalkcreation.org. Also remember to like, subscribe, and share this episode with your friends. Thanks, and see you next time.